Okay. So, yeah. The red one is the one that is the closest to 0. In this case, it's even, well, it's close, yeah, very close. Not quite, I was going to say on top of it, but the 10,000s. And then in distance, the green one is the closest, and then the blue one. But it doesn't mean that they have to be in this order, of course. I mean, if all values are positive, so all three are on the right of the 0, then yes, it must be red, green, blue. However, it could be that this green one is mirrored, say, on the other end. Then the absolute value does not change. So it would still be the second one in terms of absolute distance to x equals 0. And try that out. Let's now, green is 1.5. As you can see here, this is red, green, and blue. I'm going to put this one at minus 1.5. So, more or less. So red and blue did not change position, but green is now from 1.5 here to minus 1.5 here, which obviously then changed the order. Now we have first green, then red, and then blue. It is not possible to have blue in the middle. You can't have red, blue, green, or green, blue, red, because, yeah, I mean, this thing must be further away from the 0 than the other two. And if it is in the middle, then it would have the same sign as at least one of them. Which then determines the order such that, so in this case it has the same sign as red, and it must be further away, so it is now green, red, blue, while if blue was on the other side, then it is further away than green, so you get blue, green, red. Blue is never in the middle. So blue is either here or there, and then this is either green, red, or red, green. So there is in total 4 possibilities of ordering. And they depend on the sign, actually, of the x-coordinates of these roots. The sign of R0, R1, or R2. Let's, for example, make this negative. Now blue comes first. And in other words, put this here for a second. If R2 is less than 0, then the ordering is either R2 is less than R0. Oops, that was a top, not... huh? No. I wanted to press Control top. R0. Or this. Well, if R2 is larger than 0, then it is either this or this. Now, what determines the ordering of R0 and R1? But for now, let's just look at the signs, okay? So, the sign of R1 is, just also start with less than 0. So if both R2 and R1 are negative, like in this case, then, I mean, even if you make this like minus something, it's the green is in the middle here, because it's negative, so if red is positive. But it doesn't really matter if red is positive or negative, because if it is negative, it has the same size as green, but it must still be closer to 0 than green. So red moves at most till the green itself. So the order is now given. It's blue, green, red. Even if you move red on the make red negative as well. It doesn't really matter if it's positive or negative. So yeah, but you can move it further. No, because the absolute value of green must be larger. So if I move it down, then green just moves along. So you can't change that. So yeah, can put it like that. It's always blue, green, red. Excusez-moi. Let's just put it here. If this one is positive, that doesn't change the order, right? So this ordering is exclusively determined by the sign of green. So if the sign of green is R1 is negative, then it's first, just like here. So, oops, I accidentally closed the window. No problem. We're going to do this one, maybe up the top anyway. Yeah, because the ordering here is just determined by the sign of R1. And those are all the 4 possible orderings. However, we don't know what R0 and R1 and R2 are. We just don't know. We can only observe other stuff that is depending on R0, R1 and R2. Most notably, we can observe the sum Okay. I think this is a reaction to me. People are voting it down. It's so funny. Talking about, I was going to cancel my subscription on to ChatGPT. I'm gonna do that right now because I mean it. It's just absolutely shit. I don't want to use this anymore. My plan, maybe. That is weird. Upgrade my plan. I was still paying. Why would I suddenly get upgrade? Oh. No, it says your current plan. Okay. Manage my subscription. I'm doing this on a different monitor because before you know, they just show everyone my real name, which is not Garlowood, obviously. And everyone thought it was. Yeah, exactly. Bam, here it is on the monitor. Phone number, address, real name, everything. Okay, cancel subscription. Available till December the 7th. No, there's a lot of options they want me to choose. I guess by now it's safe to move back. What is the primary reason for cancelling? Unhappy with the limits? No. Too many technical issues or bugs? No, not really. It's not useful enough. Yeah, well, definitely not useful. That's of course a good reason to disagree with open. Well, I do, but it is not a reason for unsubscribing. I'm unhappy with the speed. Free play management. Haha, no. That's even gonna be worse, I suppose. I don't have that. The models are not advanced enough for my needs. And then, of course, you can only choose. Now I'll pick this one. I'm still evaluating. It's too expensive. I don't use it enough. I'm switching to a different platform. Auto please specify the model's responses are poor. Yeah, I'm inclined to click other and then make it a worse version of this. Not advanced enough is the models are pathetic. That's what they are. It's like a modernized Eliza. There is no reasoning, nothing. It's so bad. It's disgusting. I have no idea why anyone wants to pay for this. That's the real reason. This is not ever going anywhere. It is pathetic. Pathetically stupid. Pathetically not a word. What? I'm gonna ask Gemini, of course. Upgrade. I don't know. Pathetically not a word. Any replacements? Oh, I have to add another L. Pathetically. Summarization. Maybe an S. Nope. No, I think it is a word because I got it from here. Summarization. Right. I think I do want to have some AI. Maybe I'll try to switch back to Claude. Or, yeah, maybe I should try the other ones as well. I tried ChatGPT for 2 months now and Claude for 1 month. It was also so disappointing that I just didn't want to continue paying for it. Well, to make this extra clear, I have enough money that I don't even notice the 20 euros a month, but I generally just think it's not worth the money at all. It's just a waste of time. I would rather just go eat in a restaurant once every 2 months instead of having a TTP every day, which only wastes time. That's my current opinion. Anyway, I got this reaction. I've noticed it's really bad at math. I'll ask questions, after it gives an answer, like shouldn't the result be negative? And it replies, you're absolutely correct. Here's another answer. Yep. So, a real AI would be able to solve this. Well, I tried for 2 days on a row, and it's only spewing 100% nonsense. It's so stupid. So we'll have to do it ourselves. So I'm having the product of the roots. Let's put a minus sign in front of it because that is the constant factor of my cubic. This is literally a value that we have. And then of course the next one would be R0 times, let's do it like this, R0 times R1 plus 0 times R2 plus 1 times R2, and we have minus R0 minus R1 minus R2. And yeah, now instant problem. Apart from the first one, we have no idea what the sign is of this, of course. No idea. Or do we? Because, well, we know that R0 and the absolute value of R0 and R1 are less than the absolute value of R2. but the sum of them might still, cancel it out. So I think that you still can't say anything about the sign of this thing. And this one even less. So at first sight, I can't even say anything about the sign of this, because R0 is unknown. The sign of R0 is unknown. So these values is what we have, and that doesn't help whatsoever. However, what I did notice is that these are the vertical lines. If you look at the x-coordinate of the maximum and the x-coordinate of the minimum of the cubic, then there seems to be a correlation. For example, if both have the same sign, so the maximum and the minimum now both have a positive sign, then it seems that this must be red, green, blue. Because, I mean, if this the cubic is always the same, it's a monocubic cubic, so it goes to plus infinity here, and it comes from minus infinity. And if it crosses y equals 0 3 times, then the second time it crosses is in between the maximum and the minimum. So it must cross it before the maximum, and then it must cross it between the maximum and the minimum, and it must cross it again after the minimum. And that means that, I make this positive, that it is red-green here if they have the same size. If blue is here, must be red, green, blue. So if these two are both positive, then this one is positive. Green is in between, so that must be positive as well. And red must be on this side. And okay, it could be negative, but that doesn't change anything, because this distance is always larger than that distance per definition in this case. Okay, so this can be positive or negative, but if the maximum is positive, then maybe it also has to do with the deformation of the thing. It's not quite a parabola here, it's a parabola that is, this part is shifted a little bit, so even relative to the maximum, this thing is further away from the maximum than that thing. It cannot be closer. It can be at an equal distance, however, if we move them both very close to 0. Let's say, and I mean, yeah, now they are at equal distance, obviously. But it is equal or further away. This is always like that. Okay, so we can let me just forget about this. I'm gonna write down how want to see the value of x max. No, it's not just x max, right? It's the value of x max and x min. If they are both positive. But okay, we know x max. So if this one is larger than 0 and x min is also larger than 0, then the ordering will be R1, R0, R1, R2. This one. Likewise, if x max is less than 0 and x min is less than 0, then it has to be reversed, because yeah, if we want to have this thing, this line here on the other side, this means that green must go to the other side, doesn't it? So now it's positive, and now we move it to the other side, and at the same moment it becomes negative. So this value doesn't matter. And here, you could say, yeah, but no, because it must be further away from the x equals 0 than red. So if you move it up, you can't move it further, because red is in the way. I can make it positive, but then it jumps to a distance larger than this one, which means that, well, equal, but since, oh, wait a minute, it is negative now. It's even visible, really. The black dashes here are a little bit on the left of x equals 0. But okay, using the previous reasoning, that the deformation of the cubic is such that green is further away from x max than red, because it's dragged out a little bit like this. It's like this is the form, say. So it is possible that green is on the other side of the x equals 0 axis, while x max is negative. Just a little bit negative. Damn it. Let's see if we can pronounce that fact. Yeah, now it's clearly negative. But it jumps. I mean, there must be something you can say about it. I mean, now it's very negative, and then I do this, and then puck. What changes here? Yeah, what really changes is that it's on the other side of R0, I think. Yeah. Yeah, pretty much, of course. It's like literally, I mean, it's this area is where red is, and this area in between is where green is. So red is per definition on this side. but it can be made, the maximum can be made just negative, a little bit negative. Yeah, so what the most important thing, I think, that what changes is that now green is a positive sign, and here it has a negative sign. That's a really big difference. So at this point, the sign of this product here changes. So maybe a combination of the maximum and this product will tell us something. I just don't know. The scary thing is that it might not be possible without doing heavy calculations. I mean, I could just calculate the roots, of course. But yeah, the whole point is I want to decide based on the order of the roots which algorithm to use to calculate them. So we don't have roots, period. I could make a table, maybe, of just every possible thing I can think of. So for example, the sign of this thing, the sign of this thing, the sign of that thing, the sign of x max, the sign of x min, and whether or not the absolute value of x max is greater or less than the absolute value of x min. would that look like? This is true, right? If both are positive, it's not positive. If this one is positive, then yeah, then it must be red-green. I mean, now it's negative, but if you make it, change it even further and you make it positive, then it is red, green, blue. Now it's negative, blue is negative. Sorry, the maximum is negative. Maximum is negative. So we make the X max positive, then it is a red, green, blue. I feel pretty sure about that, but let's check if this is true. So we have a program for that, or let's write it. I have another program for that. This is cubic roots. We have small root, I think. I just try out, this is an infinite loop, and then a loop of 100,000, but basically it's infinite. And I generate the absolute value of R2 between almost 0 and 10. And then the absolute value of R1 is less than or equal the absolute value of R2. And the same thing for R0. And then I run over all possible signs, the 8 possible ways to give signs to them, which of course has no influence on the absolute value. And then we call the function roots with that. So this is calling for many different values of 3 real roots. This function, and then, well, we might as well add an assert as well. So let's say the absolute value of R0 must be less than or equal the absolute value of R1, which is in turn less than or equal the absolute value of R2. And that is the only restriction, well, apart from that they exist. So from that we can calculate the coefficients of our monocubic. I also calculated discriminant here, which means that must be always actually. I mean, because we have 3 real roots, this must be greater than or equal to 0. It just follows from the fact that we have three roots, doesn't it? Yeah, because it's the square root of d, which then must exist, is linear with the distance between x max and x min, which must exist if we have 3 roots. So I already have a few asserts in here, I see. Let me comment this out because it's not really testing anything, it's just fooling with the output. Yeah, well, okay, but does not assert, so let's add a counter, so we have a little bit of an idea how many have been processed in the meantime, or just do 100 million at most. Let me remove this one and make this 100 million. And let's say if I mod 1000 equals 0, print I. Should be 100,000. Oh yeah, times. So we're halfway now. The 50 is halfway. Good. So these definitely hold. Might even be a little bit too much output. Every 10,000. Okay, so if x min is less than 0, that means that x max is also less than 0, because x max is less than x min. I can add an assert for that, but it's kind of obvious, because x max is minus the square root, which is positive, divided by a positive number, so that is definitely going to be less than x min. And you can also see that in the graph, of course. The maximum is on the left of the minimum. So if x min is on the left of x equals 0, then x max is there too. And in that case you have this ordering. R2 less than R1 less than R0. That would be this one. Put this with the top in this column. And this one is if x max is larger than 0, then so is x min. And then we have the other one. That was this thing. So these hold, great. But it doesn't mean that if neither of these are true, okay, that the only other possibility is that x max is less than 0 and x min is larger than 0. In that case, we can find any of the four still. So you can test it out if you have this ordering, to put them in the same order. I want to begin with R2 is the smallest one now. This one. And then we do R2, R1, R0. R2, R1, R0. And then swap R0 and R1. So what is this one, I guess? Else no, well, fix that in a second. R1 first and then that one. R1, R1, R0, R2. R1, R0, R2. And then R0, R1, R2. 0, R1, R2. Yeah, and this never happens. Let's make sure of that. And I don't want to print this much. Let's just print something quick. So A, B, C, D. And we see all of them. See A, B, C, and D. Okay. So all four are possible. Yeah. Okay, so let's mirror this in the x equals y axis. Because you're going to have a lot more of these than these four. How to do that? Let's start over before I mess it up. on some kind of table where we have actually well, let's add that label that I made up. So this was A, and this is B. And this is C, and this is D. Arbitrary labels, but okay. And then this is when that is the case. And this is when this is the case. Fixing my music. Hi guys, yeah, sorry I was looking at the chat. Good Taro is here, Yassir, Parveen. Well, I had a chat on, I think. No, actually, no, sorry. I was looking at Spotify though. I had forgotten to switch back to YouTube. So these are the 4 orderings, and I want to find which one it is, and then our inputs, the possible inputs that we have are, well, for example, this. And then the opposite. And the same thing for that one. Now it's kind of silly to use both. I'm just going to do true or false, and we are going to forget about equals. Let's put x min last, like everywhere else. So the sign of x max, the sign of x min, and then whether or not the absolute value is less than or equal. Now normally x max itself is less than, so let's make a larger than here, just like here. Yeah, I'm going to do the sign of all the coefficients. And of course now everything must be shifted. I wrote in the description below the video, you scroll down, it should be there. But yeah, I just want to, the inputs, the value, I have lots of values, but not the individual values of R0, R1 and R2. Those are the roots of the cubic, so I don't have them. But if you multiply all roots, you get the constant term of the coefficient, and if you do this with the roots, you get this, the coefficient of x. So those values I do have. Now to shift it more. So I want to see if there is a relationship between the stuff that I do have. Well, if that lets me determine which column we are. I'm just going to brute force it. Just shift it even further. Damn it. I'm so not convinced that this is enough, but I'm looking at the fact that if you divide this, if you divide this by that, you get the sum of the reciprocal of the roots. If you like literally would divide it, you get minus 1 divided by R2, minus 1 divided by R1, minus 1 divided by R0. Which looks a lot like that, except that you have the reciprocal of them. So then I think we should be able to do something with this. as well. So I don't know. I just don't see it, and it's probably not true. But let me investigate this. So if I replace that with 1 divided by 1 divided by R0 minus 1 divided by 1 divided by R1 minus 1 divided by 1 divided by R2, that would be just this. And then this divided by that. So what I want to do now is multiply it by this. So we're going to divide it by that then. So I want to multiply this with, well, basically just this, but then again using the reciprocus. Yeah, we know this value because this is just that. And this is, of course, just 1 divided by that. Let me give the beasts a name, because they have a name. So this is C0. It keeps shifting. It's unbelievable how many shifts I need. And another one. Rohit, you don't need Kitash because Kitash is simply downloading, configuring GitHub projects. So if you don't use it, then you could clone it yourself and configure it yourself and compile it yourself and install it. And then you set the right environment variables for CMake to find the project. Maybe even added the CMake file to edit. No, that's not necessary. If you just compile it and install it and then install it in a place where CMake can find it. That should be enough. But if you do use Kitash, and why not, it's literally just making room on your hard disk somewhere. So you just assign some directory, set the environment variable Kitash root, I think it was. Yep. So you just set this environment variable, export it to some empty directory where you have write access. And isn't that all? And then Hitachi will automatically clone it for you in this directory and configure it according to the configuration that is in the project, and install it in a directory with a hash that is hashed by everything that would otherwise require recompilation, so all the compiler flags and the compiler version and stuff like that. For example, I have currently only one. I think you can even print it. Done. So done contains this string. So you can see what it is. This is what the hash is made of. So this was compiled with that version of Clang using the git tag master of this repository, passing this as configuration. And it was initially compiled and installed by this project on that date. And there's some random stuff here to make sure that nothing collides, I guess. So yeah, but obviously I strongly advise you to use Gitash, because it's just takes a lot of work and headaches away. If you ever run into a problem with it, like it doesn't update or something, then just delete the whole directory. So if I would delete all of this, and then you configure again, it will download it and do everything again. I can even show that. It's really easy. So if I configure my project currently, it just prints out what the configuration is. It doesn't really do much. It does print that it finds this. Is it not? Yeah, it prints this. Hitachi package libcwr is already installed, and you see where it is as well. So if I would delete this whole directory, or even this for that matter, but yeah, well, it's called cache for a reason. Let me just show you. I mean, boing, no more libcwr. If I now run the configure again, it clones it, configures it, compiles it, installs it. Oh yeah, there was a problem here. You have to do it again. I'm not really sure what the reason is for this. I think I do have a dependency order problem. But if you run into this, you have to run configure again, and then it will work. So now we have, I think, the same hash, right? Because nothing changed. So everything was installed again. So we deleted this directory. And now it's all back. So you're pretty painless, I would say. Beats having to clone it yourself and stuff. Yeah, so if we have, this is C2 because I do divide and then again divide, so this is just minus R0. And then minus R1, minus R2. And I multiply that with 1 divided by C0, which is then minus 1 divided by R0, etc. And if you multiply that out, we get, well, then this drops away against this. So we, for the first term, we only are left with this. I'm going to use the same order. So the last one gives me this. And the thing in the middle is then going to be this. Oops. Very much like this one, but then all the roots replaced by their reciprocals. But yeah, then the sign of this is, of course, well, the sign of this is same as the sign of C2 because it's just equal. The sign of this thing is equal to the sign of this thing, even though it's 1 over. So the sign of this thing is going to be equal to the sign of that thing times the sign of that thing. Or C2 divided by C0 gives me the sign of this thing. But that's why it's not really helping, I guess, because we already have those signs. So if there is any relationship between this column here, one of the 4 columns, and the signs of C0, 1, and 2, then this is not going to add any extra information. I just thought it was interesting. It is interesting. I'm now looking at the relationship between it's damn interesting because this swaps the place of R0 and R2. Because the absolute value of R0 is less than the absolute value of R2. So the absolute value of the reciprocal of R0 is larger than that of R2. So a cubic with 3 certain roots is strongly related to a cubic with the reciprocals of that root. Apparently. How would that one look like then? So the reciprocal of p. So this thing has the roots r0, r1, and r2, because they're defined like that. And now this one is going to have the roots of the reciprocal of the roots of the other one, which means that this thing is completely inverted. So that's 1 divided by C0. Okay, so this, and then we want to have the sum of the product of every possible pair of reciprocals of the roots, which is this expression. And that happens to be equal to C2 divided by C0. And then the sum of the reciprocals of the roots. How do we get that? Don't have that. That is actually C1 divided by C0, I think. If you divide this by that, that is minus 1 divided by R2, minus 1 divided by R1, minus 1 divided by R0. That's exactly what we want. Now let's multiply, I mean it's monic now, but if I multiply it by C0, then of course the roots don't change. So for now I'm going to multiply this with C0. And this too. And this too. And this too. And then you see that if it simply reversing all the coefficients. Interesting. So if we reverse the coefficients of the cubic, then the roots become their reciprocals. I don't know what I can do with that though, but it's interesting to keep in mind maybe. Let's keep it in this readme. Don't need to keep this. So how can I fill this table? Yes, you can have 0 as a root. Absolutely. Well, it's an interesting question because how would it change into having? Well, if okay, no, it's not. 0 is only a root if C0 is 0. Yeah, if x equals 0 is a root, then C0 is 0. That's the reason why x equals 0 is a root. So then this turns into a parabola, which means that the third root then is at infinity. You just have 2 roots and plus 1 at infinity. Let's make this table by filling in when it is possible, maybe? Yeah, no. Well, no. Why is this so difficult? I need a quantum computer, I think. Entangled bits. I mean, these are bits, but they are kind of entangled. If I just collapse everything in a two-dimensional array, I lose all my information. For example, if this is true and this is true, both, then it's going to be column D. But I can't put it in this array, like if this is larger than 0, I can put a star here because sometimes also this is larger than 0 and then it's going to be there, but other times it's going to be somewhere else. Maybe one of them not, but I think these three at least. And then this may be the other three. No, also this. I don't know. Looks like I would have to put this into 1 dimension, 2, 3, 4, 5, 6, 7 dimensional block, and then observe the result of that. But I wouldn't be able to do that. Yeah, what we can do is look at one block, one 7-dimensional little cube. Let's say I'm demanding that this is false, and 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 this is false. And then investigate in how many columns that occurs, if at all. Let's do that. We can extract this as well. Let's just forget about this for now. Simply test the order. And we already tested this for 100 million cubics, so I believe that. And then we have here I don't need to print it. Column is A. Oh yeah, this was also already tested. Don't need that. On the different criteria we have is this. I'll call those things, let's call them B something, the B of Boolean. So let me get an array. Probably smart in the end. An array of booleans and then a number of them. I have 6 of them at the moment. So that would be just let's convert the whole thing to a mask. B mask. Rohit says, I'm trying to enable the log messages in CMake. I'm using if I run configure, then I run actually this. Maybe you want this. I'll just paste it. I can't make it better than this. For some reason that's too long. I use the following environment. I'm using CD EH or HE to source automatically all env.source files in my directory and parent directories. and this contains this. That's a Bosch array. So then, and of course this. And this. But this is only needed for your key touch. You need these as well, I think, if you're trying to compile machine learning. So using these would limit the number of errors that you get, maximum of 2. You need this to get the TensorFlow to be found then or whatever. And this is just something that I pick myself, I think. So we're going to use this environment variable in the and these as well. And you need to set this for key touch. Maybe you need this as well, still. I think there was something changed about it, but if this exists, then you probably want to prepend it to your path. So yeah, then I use that here, right? Sorry, now I forgot what the name was. CMake configure options is a Bosch array. Yeah. So key touch root is set. You don't want to have an LD library path set. That might screw things up. So I'm also using repo base always. So this the directory of my repository, and build directory is where I build. And then you have to set CMake build type to debug. And this is the correct way then to pass the rest from the Bosch array. Okay, well, I'm gonna continue. You can always halt the video if you want to look at it longer. Okay, man, no problem. So maybe you want to use the CDEH as well. I'm kind of gave up promoting it because, yeah, I don't know. I think everyone who's using Linux and is a programmer should use it. You're just completely crazy that it isn't already gone viral, basically. I have no idea why not. I think it's unmissable. So, where did I store that? Sorry, now I'm talking about CDH. So let's just go to my home page, actually. Home page. CD. This is an old page that describes how to install it, I think. Yeah, it should be up to date, more or less. But to be sure, let me show you what I am having. So I have Bosch RC. think it's at the bottom. Yeah. So you have to add this to the bottom of your boss RC, where that is a directory, I think, with a certain mode. No. It's owned by root, and you have, I mean, in my case it's owned by root. Oh yeah, you have a history directory, which must be with the T. It's like a temporary directory. So these things you can download, and then you have to create the history directory. It's probably on that web page as well. My history directory then contains, for the users that use it, so Carlo, that's me, just everyone can read my history. And then here we have history files as a function of directory. I think that's it, right? Yeah. So you have to you create some new directory as root, and you download the stuff in it, add history, do prompt, and this env.bosh rc file. Create the history directory, can be empty. And then you add what I showed to the bottom of your .bosh rc. And then you should be set. And then you can add env.source files to directories, and they are done automatically loaded. So for example, if I go to my home directory, it says environment changed to root, because apparently I don't have I don't have an environment especially for my home directory. So it falls back to the one that belongs to the root. But more importantly, if I go to projects, it says environment changed to projects machine learning. I'm not sure if, you probably don't need it. I mean, I have a whole system built on top of this, which I use certain standard between double quotes environment variables and aliases and bash functions. For example, if I type PE, it prints all the env.source files that are being sourced in a reverse order. So first it sources this, and then it sources that. I'm not sure who is defining PE though. Probably this one, now I think about it. So you probably get that as well. Let's see if this is in here. Yeah, it is. At least it should be. You get the prepath, add path, prepath, del path as well. No, it's not. There's no PE in it. Well, then it has to be in this. Got to be loaded somewhere. No, also not. No, I don't know. I don't know where my PE is set. No. I'm also pretty sure I have other aliases related to CDH, but I can't even remember them. Oh yeah, resource. I use resource a lot. This is resources to files. If you make a change. Just can't remember where I defined the resource thing. If you use it, you probably want to have this as well. And that. You're not on the Linux. Different. No, I mean, yeah, let me continue with my project. Yeah, so now for one particular slice, namely everything is false, I want to know in which column then cubics can occur. And it should be only this one, even based on just the first two, right? Or this one, I mean, it's just one of them. Just because of the making everything false means that these are both negative. So that would be this one, which is the first column. Do small out. Okay, let's do this. If bi will this convert the array to a bit mask? If everything is false, then print yeah, print column. I just want to be able to print it. Maybe you should add some utility to easily turn an enum into something printable, because it probably needs C++26 for that. Or magic enum, but I don't want to use that all the time. Annoying. The AI case return is a statement, a single statement. So if you do something while without semicolon, then you're sure that it is seen as a single statement. And the statement is case X, return stringify X. So that's exactly what we want, and then of course we need a semicolon after it. And the never reached has a semicolon because it mimics that we never even get there. let alone that we get after it. So I don't want to put the semicolon here, because that would indicate that we would reach the semicolon. So I'm like, yeah, we never come here. So, and if we come here, we never even leave this statement. So the semicolon should not be needed. But of course it is needed, so but I put it here. The statement being that if we get there, we just assert. But I tell the compiler that we'll never get there. So it's not complaining about not having a return type here. Tell the compiler that this is never reached, so we don't need a return type now. No, nonsense. I do write it to string order. Macros, yeah. Okay, what the heck. Oh, never mind. That is this thing here. Now I found it confusing. It's not print anything at all. Yeah, nothing, right? So it's never happening that everything is false. Yeah, well, in the true sense of the quantum mechanics, as I said, we would need, you just have to look at every combination as a separate state. So we just have to print the result for each of the possible masks. There's no other way. What we really want to do is okay, 6, that is 2, 4, 8, 16, 32, 64. There are 64 possibilities for these combinations, and each is then linked to 0 or more orderings. And the question that I cannot answer is it even possible that it is ever linked to 2 orderings at all? Hopefully not, but theoretically possible. But is it? So let's make an array. I'll just make it a global array. Yeah, array. An array of unsigned ints. Nah, it's a mask, but int is my mask, and then we have 64 of those. That's bullshit. So different mask then. Okay. How shall I call this thing? Table. Brilliant name. Int. 1 is A, 2 is B, 4 is C, and 8 is D. Sure, if I need it, maybe I should add int as well. So that's the meaning of this int here. Now we use bmask as index. Oops. Did that line instead. No, might as well start with checking that there's only ever one bit set. So that is 1 bit means that is a power of 2 is power of 2. Hey, it gets a color. Which of course is defined in utils is power of 2. And that is unfortunately core dumping. And then it's not a power of 2. So we run this for a while, then at some point the table doesn't change anymore. No. Oh, do you print something as bits? Fuck, why I cannot remember that. It's one of those blackouts where you just suddenly don't know something that you should know. Beats me. How to print an int in a binary in C++. Bit set. Bit set? No, I thought there was another way. No, maybe it is bit set. I'm just confused that it is that you have to specify the number of bits, but maybe that's not weird at all. So it was bit set, okay. How many bits? These, right? So 6 bits. No. Yeah, this one is it. Yep, a maximum of 6 bits. And that gives me then the order. It's a column. Holy shit, that stopped quickly. What? I had expected this to flood with text. That is really shocking. Impossible. Well, maybe not impossible. Highly correlated. Oh, this seems to be everything. What? First things that come to mind is must be a bug in my program. This can't be right. What the hell? I'm shocked. Can you hear that? I'm shocked. I had so not expected this. Almost nothing, man. Okay, let's put all the A's up at the top. I mean, I can even do this manually from here. That's A. What? Really? No, I'm still thinking that this can't be it. Can't. It's impossible. Impossible. There should be, there's probably a bug somewhere, right? A serious bug. I'm not seeing something. No, let's try to simplify this. Let's put in order, or what do I see? See, this is an interesting one. If the last two are both 1, then it's G in all cases. Because none of these have that. But it's also D in this case. Which means that this one is set and this one is set. And now the question is, of course, does that happen? Yeah, here. Uh-oh. There we have a problem. So this mask gives me both C and D. That means that we can't distinguish them. Shit. Uh-oh. No, see how many duplicates we have. That's always A, always A. Ah, fuck me. Let's put the ones that are duplicated at the bottom. Also 3 of them. Yeah, I guess these are the same as A. I have 4 here and 4 here. Yeah, I have to distinguish between these. Yeah, okay. There is another equivalence, I think, if you... I was thinking if you negate both x and y, what does that mean? Mirror, mirror. That is... is it not reflecting in the origin? So then the shape of the cubic doesn't change. And the roots do not change as a result of flipping y, but they do change as a result of flipping x. So all the roots are inverted, while the shape doesn't change. Which then in turn inverts all the coefficients. Except the monic one, of course. No, it's not true. We just only C0 is flipped because C0 is three roots multiplied. So if you change the sign of all three roots, then that coefficient change sign, and then we have the addition as well. So the constant and the x squared coefficient swap sign. But x swap sign as well. So the x and the x to the power of 3 must be negated as well. So the whole thing is negated. I thought it meant you should just negate two coefficients. Why is negated? Let's type it out. Do we have? Let's go to the README actually. The README I was writing. So we have this. Yeah, so if C0 was this, so if just all roots swap sign, then C0 swap sign. And if all roots swap sign, then C1 is not changing, and C2 also swap sign. So the result of swapping x and y is that all the roots swap sign. Which is because you swapped x. But the shape doesn't change because you also swapped y. Let me see. It does switch. I think the x max and x min are also swapped sign. So this changes. This changes. If these two swap sign, that does not change. Therefore, the absolute value doesn't change. So if either. And this changes, and this does not change, and this changes. Let's look at. Yeah, no, I don't know. B0 is the least significant bit, which is the one at the top. So again, let's begin with this one. So all the root swap, this swaps, this did not swap, this changes, this did not change, and this changes and this changes. I remember that. 5 3 octal. Oh my god, why did I do that octal? No, I want to go back to my readme. No, I don't. I want to go back to the tool file. So we toggle all these bits, these 4 bits, and that means that we toggle the sign of all roots, which means that we did mirror the thing in x and y. And that's equivalent in a sense. So I wanted to see what patterns I get from that. Let's put it below here. So swap this sign and not this one and this one and not this one and this. That's something entirely new. That's kind of weird. Yeah, huh? Now maybe I did something wrong then. Can't be right. No, forget it. one thing jumps out. This bit is not important at all, and also not here. And then again not here and not here. But here it is important, because if it is 0 then it's definitely a C. And if it is a 1 then it could also be a B or a D. Yeah, and the same thing here. This thing, if it is a 1 is a B, but if it is a 0 it could be one of these. But in these cases it's not important. In fact, these are just determined by 1, 1, and these are determined by 0, 0. Rohit, thanks man. Yeah, it's going slow. I'm struggling myself, trying to figure out how this works. Well, I'm still so confused about the very few values that we get for B mask. I suppose it makes sense. It actually makes sense. Of course it makes sense. Yeah, it definitely makes sense. There should be only a few. Because the inputs are 3 roots, the sine of the roots, you know, you kind of expect 8 values and then, or yeah, maybe, I mean, it's okay. Let's try adding a search with things that I know small. We already saw these 0, 0 and 1, 1s here. Already had that assert even. So if these two are set, then it must be a D. Yeah? And wait a minute, if they are set, it must be a D. If they are not set, then it must be an A. So that's this and this block. And I can add an assertion for that one. I don't want to have to test everything though. But how many bits do I need to distinguish this case? I can just try to toggle each of the bits. So I have 6 bits. Toggle this one, toggle this one, toggle this one, toggle this one, toggle this one. I'm missing one. This one. Yeah. But that one is unique, so I don't need that bit then. Also unique, so I don't need that bit. That bit we definitely need. So that is toggling this bit here. So this bit is needed. That one we don't need. That one is needed. Which did I toggle here? This one? No, this one. Also not. So don't care, one. Don't care, one, don't care. Nobody believes that. Nobody believes that. Wait a minute. Don't care is a bit much. I do care. What's the space there? Okay, let's make my don't cares 0 or 1. Right, so I definitely care about certain combinations. The first bit, I could say. I mean, I need one more bit, and if I set the first bit, then it is sufficient. There we go. Yeah. Can do the same thing here, I suppose. No, also the first one. Or the third one. Could I also have used the third one here? That is a 1. Yep. Let's use the third one. For no apparent reason. No reason at all, actually. And then let's do that here as well. That was this one, yep. Do I use the third one, this one, which is a 0? Yep. Dot exclamation mark, the third one, dot exclamation mark. So it's just demanding 3 zeros, is that? Yep, that's what I did. Okay, and then all of these are that, and all of these are that, and these will remain a problem for now. Let's test this. This mask is obviously E or 14. No. This one, right? So 14 is equal to 14. Third column equals this one, B. And this is 1 less, so that's 13. Yeah? They must be all zeros. And then if you really want to test everything we learned, we could say that, well, if the mask equals this, then it's not D. But, no but. And I might as well use the complete value. So this is 6 plus whatever this is, 32. 32 plus 6 is 38. And this is 10. And then it's not A. No, that works. But yeah, no distinguish thingy yet. So I think I need a few examples. I guess I can print a root every time it has one of those values, the roots, and then we can look at it. Maybe get some inspiration. I think I'm going for a walk, not because I want to, but I have to. I need to have more exercise. In fact, I hate it. I would like to go for a walk if I have something to think about it at the same time. Yeah, can wait till 100 millionth cubic, but I believe it. So these two cases are problematic because sometimes it's one, sometimes it's the other. Let's concentrate on one of them and then we print out, well, I guess the order. And just print out the roots because I want to visualize them in my other program. I think I might learn most of it if they are as far apart as possible in absolute value. I mean, I don't want to test all of them. So Yeah. So we're going to test, say, going to determine the absolute value of something. R0. Yeah, it says default constructed or just filled with zeros. Static is filled with zeros. Not convinced that a double all filled with zeros is actually double. Is a valid number, which is 0. If you do this, you kind of want to initialize it. So if it compiles, I would say it fills it, and then it should fill it with default constructed doubles, which doesn't exist, but that's probably going to be 0 then. Probably. Okay, so if the minimum absolute value of these things here, distance between 0 and R0, and the distance between R0 and R1 in absolute value, and between R1 and R2 in absolute value, and then the minimum distance of that, if that is larger than one we saw before, then we print it out. So in the end I should see for each different column at the bottom the one that has those distances being the largest, or the minimum distance is the largest. Looks like 1/3, 2/3 and 10. Oh no, we go to 7. Never mind that. Yeah, could it be equidistance? So if it is 10, then the other two are between 1/3 of 10. Yeah, that's 3 1/3. Yet we went to this instead of 3 1/3. That is really weird. Oh, but that's for D. For B and C, it's indeed about at 1/3. Just all the distances are equal. 3 1/3 for R0, and then again a distance of 3 1/3, and then again a distance of 3 1/3. But the D prefers something else, and A we don't have. No, let's do B first. The only difference between C and B is swapping the signs of those. Interesting. Can't do 3 1/3, however. I have to change this program first. Cubic roots 2. Slider must run from slider. Hmm, 4.15. B 3 1/3. What the hell? Yeah, no way, of course. Maybe they became equal, maybe they became equal. Yeah. I don't want that to happen, but I don't want to assert on it either. I'm gonna have a different approach, I guess. Let's put this one at 9 first. 9.98. Okay, 10 it is. And then this one at 7. And now this one at, no, damn it, I wanted to do this one. B, gotta be minus 10. And that one was 6.6. And then this 1, 2, 3, 1/3. Like that. Right. Okay, let's change the values a bit. Well, apparently I can't put it on 4, or it just the distance is just less. This is the optimal equal distance. But okay, maybe I should try this one. 4 points. So I'm just gonna put this at the maximum. That would be, the order is still the same. Yeah? It's now blue, red, green, which is B. Should be B. Okay. Blue, red, green. Yep. This is B. Still B. And I'm gonna put this one on, I can put this one on -10, of course, and then this one, let's say about 7 should work. Still B. And then apparently, if we just swap the last two of sign, so make this a negative and that one, well, sorry, make, we are here. So we make this negative and make this positive, then we change to C. Which is green, red, blue. Yep. And then D is also possible by making this one negative and those two positive. Yep. This one is already positive, so we toggle these two. Yeah. I'm gonna put this back on 7 and then this at minus. which apparently wasn't necessary. This should be D, red, green, blue. Red, RGB, yeah. Default. Default as in R0, R1, R2. However, you see that we keep that same order if I put this on just very close to 0. Even on top of 0. It really doesn't matter where that one is. So the sign doesn't matter either. And that was the D case. What about... Go back to B and C. So put this one now at 3 1/3. And... well, actually... positive, negative. Okay. Put this negative. Yeah. So this was, well, this order. And again, it doesn't absolutely not matter whatsoever what that thing is. And if we swap these two signs, so this is positive and this one is negative. Then we have this order, and again, actually it doesn't matter whatsoever what that sign is. So we might as well put it at 0. And so if this is 10 and R1 is well anything between minus 10 and 0, then we have this order. aka it is negative. And if we make it positive, just D2 swap as usual. If you put this thing on the other side, then it's still the same thing, but then with blue on the other side. So that's how we get 3 orders. This is 1 order, 2 orders, well, 3 orders, 4 orders, get all 4 orders. This has to be at least 7 because... no, it doesn't have to be. Okay, let's run this program again, but now trying to get trying to get R0 as close as possible to 0, which means as far away as possible from 10, for example. Oh, shockingly, only C goes to 0. No, 2 is wrong. It's not what I wanted. All three go to 0. Is that the result of this one? Oh mooi. Great. Shit. How the hell does that happen? It's getting dark outside. Yeah, well, I'm gonna go for a walk because I don't want to walk in the dark, so. Again, another day of failure. This problem is maybe impossible, I don't know.